Welcome to Projectventive channel. To make sure to hit the like button and please subscribe this channel. Stephen Wolfram is a British-American computer scientist, physicist, and businessman. He is known for his work in computer science, mathematics, and theoretical physics. In 2012, he was named a Fellow of the American Mathematical Society. He is currently an adjunct professor at the University of Illinois Department of Computer Science. As a businessman, he is the founder and CEO of the software company Wolfram Research, where he works as chief designer of Mathematica and the Wolfram Alpha answer engine. Wolfram Research is one of the world's most respected computer, web and cloud software companies, as well as a powerhouse of scientific and technical innovation. Stephen Wolfram has had a unique trajectory in science, technology and business. Widely known for his discoveries in basic science and his groundbreaking 2002 book, A New Kind of Science, he has spent 3 decades building what is now Wolfram language, the knowledge-based computer language that powers Mathematica and Wolfram Alpha, and has contributed to countless inventions and discoveries, as well as to the education of several generations of students. Wolfram products. Wolfram's flagship product is the technical computing program Wolfram Mathematica. Other products include Wolfram Alpha, Wolfram System Modeler, Wolfram Workbench, Grid Mathematica, Wolfram Finance Platform, Web Mathematica, the Wolfram Cloud, and the Wolfram Programming Lab. MAJOPRPRODUT that build up future. Wolfram Notebook Embedder. Wolfram Client Library for Python. Wolfram Web Engine for Python. WordPress Notebook Embedder plugin. Wolfram Language for Jupyter. CloudConnector for Google Drive. CloudConnector for Excel. The work of Wolfram that utilize computation meet knowledge. 1. Complex systems and cellular automata. In 1983, Wolfram left for the School of Natural Sciences of the Institute for Advanced Study in Princeton. By that time, he was no longer interested in particle physics. Instead, he began pursuing investigations into cellular automata, mainly with computer simulations. He produced a series of papers systematically investigating the class of elementary cellular automata, conceiving the Wolfram code, a naming system for one-dimensional cellular automata, and the classification scheme for the complexity of their behavior. He conjectured that the Rule 110 cellular automaton might be Turing-complete, which was later proved correct. Wolfram's cellular automata work came to be cited in more than 10,000 papers. Wolfram worked on simulations of physical processes, such as turbulent fluid flow, with cellular automata on the connection machine alongside Richard Feynman, and helped initiate the field of complex systems. In 1984, he was a participant in the founding workshops of the Santa Fe Institute, along with Nobel laureates Murray Gell-Mann, Manfred Eigen, and Philip Warren Anderson, and future laureate Frank Wilczek. In 1986, he founded the Center for Complex Systems Research, CCSR, at the University of Illinois at Urbana-Champaign. In 1987, he founded the journal Complex Systems. Please subscribe this channel. 2. Symbolic Manipulation Program. Wolfram led the development of the Computer Algebra System SMP, Symbolic Manipulation Program, in the Caltech Physics Department. A dispute with the administration over the intellectual property rights regarding SMP, patents, copyright, and faculty involvement in commercial ventures, eventually led him to resign from Caltech. SMP was further developed and marketed commercially by Inference Corp. Of Los Angeles during 1983 to 1988. 3. Mathematica. Wolfram left the Institute for Advanced Study for the University of Illinois at Urbana-Champaign, where he founded their Center for Complex Systems Research and started to develop the computer algebra system Mathematica. Please subscribe this channel. 4. A New Kind of Science. Wolfram worked on his controversial book A New Kind of Science, which presents an empirical study of simple computational systems. Additionally, it argues that for fundamental reasons these types of systems, rather than traditional mathematics, are needed to model and understand complexity in nature. Wolfram's conclusion is that the universe is discrete in its nature, and runs on fundamental laws which can be described as simple programs. He predicts that a realization of this within scientific communities will have a revolutionary influence on physics, chemistry, biology, and the majority of scientific areas in general, hence the book's title. The book was met with skepticism and criticism that Wolfram took credit for the work of others. Please subscribe this channel. 5. Wolfram Alpha Computational Knowledge Engine. Wolfram announced Wolfram Alpha, an answer engine. Wolfram Alpha later launched in May 2009,
and a paid-for version with extra features launched in February 2012 that was met with criticism for its high price that was later dropped from $50 to $2. The engine is based on natural language processing and a large library of algorithms. The application programming interface allows other applications to extend and enhance Wolfram Alpha. 6. TouchPress. Wolfram co-founded TouchPress along with Theodore Gray, Max Whitby, and John Cromie. The company specialized in creating in-depth premium apps and games covering a wide range of educational subjects designed for children, parents, students, and educators. Since the launch, TouchPress has published more than 100 apps. 7. Wolfram Language. Wolfram officially announced the Wolfram language as a new general multi-paradigm programming language, though it was previously available through Mathematica and not an entirely new programming language. The documentation for the language was pre-released in October 2013 to coincide with the bundling of Mathematica and the Wolfram language on every Raspberry Pi computer, with some controversy because of the proprietary nature of the Wolfram language. While the Wolfram language has existed for over 30 years as the primary programming language used in Mathematica, it was not officially named until it is not widely used. 8. Wolfram Physics Project. Wolfram announced the Wolfram Physics Project as an effort to reduce and explain all the laws of physics within a paradigm of a hypergraph that is transformed by minimal rewriting rules that obey the Church-Rosser property. The effort is a continuation of the ideas he originally described in A New Kind of Science. Wolfram claims that, from an extremely simple model, we're able to reproduce special relativity, general relativity, and the core results of quantum mechanics. Physicists are generally unimpressed with Wolfram's claim, and state that Wolfram's results are non-quantitative and arbitrary. Major project Wolfram API. Built on the same technology as the Full Results API, the simple API generates full Wolfram Alpha output in a universally viewable image format. This API makes it easy to translate free-form linguistic queries into in-depth, formatted results for users with little coding effort. Wolfram is big technology projects over the years. Wolfram Alpha as a practical matter is by far the most complicated, with the largest number of different kinds of moving parts inside it. And actually, it builds on something I've been working on for 25 years. Which is a system called Mathematica. Which is a computer language. That, I guess one could say, is these days by far the most algorithmically sophisticated computer language that exists. Mathematica is the language that Wolfram Alpha is implemented in. And the point is that in Mathematica, doing something like solving a differential equation is just one command. That's how we managed to implement all those methods and models and so on. We're starting from this very sophisticated language we already have. Wolfram Alpha is still about 15 million lines of code in the Mathematica language, though. Wolfram Alpha is about knowing everything it can about the world, with all its messiness, and letting humans interact with it quickly using natural language. Mathematica is about creating a precise computer language that has built into it, in a very coherent way, all the kinds of algorithmic functionality that we know about. Over the past 25 years, Mathematica has become very widely used. There's broad use on essentially all large university campuses, and all sophisticated corporate R&D operations around the world. And lots of things have been discovered and invented with Mathematica. In a sense, I see Mathematica as the implementation language for the idea of computation. Wolfram Alpha is where that idea intersects with the sort of collective accumulation of knowledge that's happened in our civilization. Computation is a much stronger concept, and actually my guess is it's going to be the defining concept for much of the future of human history. Please subscribe this channel. Major coverage areas. Units and quantities. The Wolfram language allows you to do arithmetic not only with symbols and numbers, but also with units. The Wolfram language's integration with Wolfram Alpha allows for a sophisticated unit system that combines the flexibility of free-form linguistics with the computational power of numerical and symbolic algorithms. The units framework integrates seamlessly with visualization, numeric and algebraic computation functions. It also supports dimensional analysis, as well as purely symbolic operations on quantities. Convert time. Date and time computations. Calculate the answers to countless questions about the past, present and future with Wolfram Alpha's powerful algorithms for date and time computation and extensive knowledge of history. Compute the difference between any two dates and times. Calculate the time remaining until a holiday or other specified event, or explore sunrise and sunset times, global holidays and notable historical events for any day of the year.
In statistics, the Wolfram statistics solution includes powerful optimization and statistics functionality alongside unique capabilities like free-form linguistic input, instant interactivity and the reliability of any precision numerics and symbolic analysis. Game design, special effects and generative art. Move ideas and algorithms from artistic concepts or graphics research to computer games and special effects. Rapidly prototype and validate models and instantly visualize your results, all in one system, with one integrated workflow. The Wolfram solution for game design, special effects and generative art provides a uniquely flexible framework for creating realistic games and animations using high-precision physics, advanced 2D and 3D graphics primitives, artistic color schemes and built-in geometric art entities. Medical computations. From nephrology to cardiopulmonary medicine, medical formulas are used to assess and predict physiological states of individuals. Wolfram Alpha is capable of computing a wide range of physiological and health-related quantities, including blood oxygen level, creatinine clearance and peak expiratory flow. In knowledge. With the breakthrough knowledge-based Wolfram language, students can use tiny amounts of immediately readable code to create programs that involve real-world data, generate impressive graphics and explore an immense range of computational topics, learning not only coding, but also broad STEM skills. In technologies. Over 3 decades, Wolfram has progressively built an unprecedented technology stack that has led to many transformative developments and that promises ever more in the years to come. Wolfram language. Wolfram Data Framework, WDF. Wolfram Engine. Wolfram Cloud. Wolfram Universal Deployment System. Wolfram Algorithm Base. Building the world's largest web of connected algorithms. Please subscribe this channel. Thanks for watching.